Assalamualaikum and hello everyone. My name is ALYAA FARZANA binti WAHAB, MATRIC number A211502, and today I will presenting an academic review of a research poster titled Microplastics Accumulation in Landfill Soil of Terengganu, Malaysia. Firstly, we will look at introduction. To provide some context, plastic packaging represents over a third of a global polymer production, yet up to 85% of the Malaysia's waste ultimately ends up in landfills. Within these environments, microplastics undergo continuous physical weathering, photolysis, and mechanical compaction. Over time, this breaks them down into secondary microplastics. While aquatic microplastic pollution has been heavily studied in Malaysia, terrestrial landfill environments remain critically underexplored, despite acting as a major terrestrial plastic reservoir. Next, to address this knowledge gap, the study set out with three core objectives. First, to quantify the total abundance of microplastics in landfill soils. Second objective is to characterize their physical profiles. And third, to evaluate their surface morphology, polymer types, and heavy metals absorption. For materials and methods part, the samples were collected around 11 surface soil composite samples from random stations across the active Sungai Ikan landfill in Kuala Nerus, Terengganu. The microplastics were extracted using density separation with zinc chloride solution, followed by 35% of hydrogen peroxide digestion to remove organic matter, and finally it's isolated via vacuum filtration. Then it utilized using stereo microscopy for physical sorting, which SEM EDS for surface mapping, and ATR FTIR for polymer identification. Moving on to the key findings. As you can see from the first chart, microplastics were detected across all 11 sampling stations, yielding a staggering total abundance of 37,005 items per kilogram of dry weight. The concentration ranged from 1,615 to 5,715 items per kilogram. Notably, Station 9, which located near the active waste compaction area, exhibited the highest abundance due to the direct mechanical fragmentation. When looking at their physical profiles, fibers and fragments heavily dominated the samples, accounting for roughly 34% each, followed closely by films at 31.6%. The immense presence of microfibers correlates directly with the large amount of discarded clothing observed at the site. In terms of sizing, type 1 particles, which are smaller than 0.3 mm, predominated at 48%, proving that extensive environmental weathering is constantly reducing these plastics into highly minute fractions. Color-wise, transparent microplastics were the most prevalent at 42.7%, which points back to the degradation of single-use food packaging and water bottles. If you direct your attention to SEM imaging results, the surface morphology revealed that there's a severe structural damage. Researchers observed there's a deep cracks, fractures, holes, and numerous adhering soil particles. This rough, weathered surface drastically increases the surface area of the microplastics. Consequently, the result of EDS elemental analysis detected highly hazardous heavy metals, especially mercury and cadmium, bound directly to the plastic surfaces. Chemically, ATR FTIR spectroscopy successfully identified polypropylene and polyamide as the dominant polymer types among the samples. These polymers match perfectly with the heavy influx of everyday municipal waste, such as plastic wraps, bags, and synthetic textiles. When compared internationally, the contamination levels at Sungai Ikan landfill are notably higher than those reported in landfills across India, Iran, Korea, and the Gulf of Thailand. However, they remain lower than the ultra-high density municipal landfills found in China and Indonesia. The critical takeaway from these results is the clear environmental threat they pose. The combined effect of extreme physical weathering and toxic heavy metal absorption means these microplastics are transforming into toxic vectors. They present an immediate risk of leaching dangerous chemicals and heavy metals directly into adjacent soils and regional groundwater tables. To sum up, this study confirms that the Sungai Ikan landfill acts as a massive terrestrial repository for highly weathered secondary microplastics. These findings provide vital baseline data that underscores an urgent need for targeted landfill management policies and enhanced leachate filtration systems in Malaysia. That's all from me. Thank you for listening.